Law of sines. A triangle that does not contain a right angle is called an oblique triangle. Here we have an oblique triangle with two angles given, and also we have the side across from one of the given angles given, and we're asked to find the length of the side across from the other given angle. That's the value of x that we're asked to solve for. Now, because we're not given any right angles, because it's an oblique triangle, in order to analyze it, what I'm going to do is I'm going to drop an altitude from this angle to create right triangles. So when I drop that altitude, I'm going to label it as h, and it actually creates two right triangles, one on the left with a 20-degree angle labeled, one on the right with a 45-degree angle labeled. Let's analyze the one on the right, since we're given both that angle and the length of the hypotenuse. The relationship I'm looking at here is the sine, because the sine of 45 degrees would be the ratio of its opposite side h to the hypotenuse 10. So I have that the sine of 45 degrees is h over 10, opposite over hypotenuse. If I want to solve this for h, I can multiply both sides of the equation by 10 to get 10 times the sine of 45 is equal to h. So there I have the value of the height. I know how tall this triangle is. Let's look at the other triangle now, the one with the 20-degree angle. And I look at this and I see that the same ratio applies here. I have this 20-degree angle, and I'm looking at the side opposite it that I know to be 10 times the sine of 45 degrees, and the hypotenuse, which is x, what I'm solving for. So I have that the sine of 20 degrees is the opposite h over the hypotenuse x, and I can solve this for h by multiplying both sides by x. I get x times the sine of 20 degrees is equal to h. Because they're both equal to h, they're both equal to each other, so 10 times the sine of 45 degrees is equal to x times the sine of 20 degrees. And I can solve for x by dividing both sides by the sine of 20 degrees. So here I have x is 10 times the sine of 45 degrees divided by the sine of 20 degrees. And if I type that into my calculator, making sure I'm in degree mode, I'll get x is approximately 21. So that is the value of x. Let's actually look at a proof of the law of sines. So to generalize that process, here we have the same oblique triangle, and I've taken the liberty of already extending the height. So we already have h here, but I've labeled the angles generically as just capital A and capital B. And the side across from capital A, I labeled as lowercase a, and the side across from angle capital B, I labeled lowercase b. So let's look at the triangle on the right first, the one with angle B in it. And I see that I have the opposite side and the adjacent for angle B, so that's the sine again. The sine of angle B is the opposite, which is h, over the hypotenuse, which is a. And if I solve this for h, I get a times the sine of b is equal to h. Let's look at the other triangle now, the one that has angle A in it. And the sine of angle A, it turns out, is the opposite h over the hypotenuse b, so the sine of A is h over b. And to solve this for h, I can multiply both sides by b. So I get b times the sine of A is equal to h. So if they're both equal to h, then they're both equal to each other, which means that b times the sine of A is equal to a times the sine of b. And if I divide both sides by lowercase a times lowercase b, the lowercase b's cancel on the left, leaving the sine of angle A divided by the length of side A equals, and then the a's cancel on the right, leaving the sine of angle B divided by the length of side B. This is the law of sines. What the law of sines says is that if you have an oblique triangle, then the ratios of the sine of an angle to the length of the side across from that angle, those ratios are proportional for all the angles and lengths of sides in the triangle. So basically, the sine of angle A divided by the length of side A is proportional to the sine of angle B divided by the length of side B, and the sine of angle C divided by the length of side C. So let's take a look at an example here of the ambiguous case. The ambiguous case is when you're only given one of the angles in the triangle, you're given the side adjacent to that angle, and you're given the side opposite that angle. So that's angle and then side adjacent and side opposite. In order to analyze this, since I don't have any right triangles, I'm going to go ahead and drop an altitude again. And that altitude, well, it forms a right triangle with 20 degrees as the angle opposite from this height, and the hypotenuse being 15 degrees. So if I wanted to know this height, I know that the sine of 20 degrees is equal to this height divided by 15, which is the hypotenuse. So that means that that height is equal to 15 times the sine of 20 degrees. When you type that into a calculator, you get that that height is approximately 5.1 unit. Now the opposite side is only 4 units long, so the opposite side is less than the height. Whenever the opposite side across from your given angle is less than the height that you calculate by the sine of the given angle times the side adjacent to it, whenever the opposite side is smaller than that height, you're not going to get a triangle, because if you try to find an angle where it's going to connect, it'll never connect because it's not long enough. So in the case of the opposite side being smaller than the height, we get no triangle. So in order for this to actually connect, the opposite side has to be longer than 5.1. If the opposite side is exactly equal to 15 times the sine of 20, which is approximately 5.1, you get a perfect right triangle. But if it's longer than 15 times the sine of 20, like for instance, let's say it's 10 units long, then you actually get a triangle here. But you have to be careful, because what I have here is, even though the opposite side is longer than the height, so even though the height is smaller now than the opposite side's length, the opposite side is still smaller than the adjacent side. 10 is still smaller than 15, which means not only do I have one triangle here with a length of 10 for the opposite side, there could also be this second triangle that has a length of 10 for the opposite side. So I actually have two triangles here. So one of the angles, let's call it x1. That's for that bigger triangle. That's x1, and of course the opposite side there is 10. But there's another triangle that you can form. Let's call that angle x2. Notice that's an obtuse angle while this one is acute. That length is also 10. So in the case where the opposite side, which in this case is 10, is between the height, so it's long enough to connect, and the adjacent side, so not only can it connect, but it can connect in two different ways, you get two different triangles. So we're going to find both of these angles, x1 degrees and x2 degrees. Let's find x1 first. So the same way we found it before, we're going to use the law of sines. So the sine of 20 degrees divided by the length of the side opposite 20 degrees is equal to the sine of x1 divided by the length of the side opposite x1. So that's how I get the equation here. It's just the law of sines. And I can solve this by multiplying both sides by 15, and that gets the sine of x1 by itself. But then to finally solve for x1, all I have to do is take the arc sine of both sides. So the arc sine of the left side is the arc sine of 15 times the sine of 20 degrees over 10, and the arc sine of the sine of x1 is just x1. The arc sine and the sine are inverses of each other. If you type this into a calculator and you're in degree mode, you should get that x1 is approximately 31 degrees. So I found the value of x1, 31 degrees. Now I can focus on finding the value of x2 for the other triangle. So I found the angle that I was looking for the bigger one. Now let's focus on the smaller one. So for this triangle, what I'm looking for is I'm looking for another angle that has the same sine as a 31 degree angle. So let's look at the geometry of it. Here's the 31 degree angle. Having the same sine means having the same y value. To have the same y value of an angle in the first quadrant, you have to be in the second quadrant, because angles in the third and fourth quadrant have negative y values, while angles in the first and second quadrant have positive because angles in the third and fourth quadrant have negative y values, while angles in the first and second quadrant have positive y values. So the angle I'm looking for would have to be in the second quadrant, and it would have to have the same reference angle as the 31-degree angle, which would be 31 degrees. So this is the angle I'm actually looking for, which is actually supplementary to the 31-degree angle. So if I take 180 degrees and I subtract 31 from it, I'll get the angle I'm looking for, x2. So this angle x2 is actually 149 degrees. So I found both triangles' x values. So the x for the first one, the bigger triangle, was 31 degrees, that's x1. And the second x value I found here is 149 degrees. So I found both triangles there. Let's look at another example. So I went from 4 for the opposite side to 10. And now I'm going to go from 10, I'm going to extend it even longer. I'm going to make it 17 units long. So in this case, it's no longer smaller than the adjacent side. In this case, the adjacent side is smaller than the opposite side. Because the adjacent side is smaller than the opposite side, even if I try to swing it in, there'd be no way of making a second triangle. That opposite side would be too long. So in this case, I only have the one triangle. So one triangle. So what I'm going to do is I'm going to focus on finding the value of x over here. So solve for x. Let's see. I'm going to use the law of sines, which says that the sine of 20 degrees divided by the length of the side across from it, 17, is equal to the sine of x degrees divided by the length of the side across from it, 15. I can multiply both sides by 15, and I'll get 15 times the sine of 20 divided by 17 is equal to sine of x. And then I can take the arc sine of both sides. So I'll get that the arc sine of 15 times the sine of 20 over 17 is equal to x. Typing that into a calculator and making sure I'm in degree mode, I get that x is approximately 18 degrees. And this is how you apply the law of sine.